Okay, guys, good morning. So in our last session, we talked about those parallel lines cut by a transversal, which is what we see over here with number 2. Prior to that, we had talked about vertical angles, which we see over here with number 1, and then we had done complementary and supplementary angles before that. And part of what we did the last session was we did some of this, right? And we said there's a lot of different angle relationships you can use to find some of the missing angles, right? Like angle C is 50 because it's corresponding. Angle A is 50 because it's vertical. And then, we can use some of the other angle relationships from there. But one of the things that I didn't do with you when we did that was use the interior of the triangle because we hadn't really discussed that yet. And that's really what we're going to talk about for the next couple days. So how many degrees do we have in a triangle? A triangle has 180 degrees of interior angle measure. The easiest way to kind of prove that without using a protractor is just to take a square, right? So we know that or a rectangle, but a square is easier. We know that a square is going to have 4 90-degree angles, and we cut it diagonally, right? So right now, those 4 90-degree angles means my quadrilateral has 360 degrees, which we may or may not have time to get to a lesson on interior angle of a quadrilateral, but it's essentially the same as today's lesson anyway. But if we cut that in half, now we cut those 90-degree angles in half, so they're both 45 degrees. But more significantly, we've got this triangle here, which has 90, 45, 90, 40, 90, 45, 45, which is 180 degrees, right? If we have an equilateral triangle, as we see here, or now we see here, now that I've labeled it appropriately, we would have 360-degree angles. So we want to be able to write equations to find the missing angles. Now, obviously, we don't need an equation here, but if they were all algebraic expressions, which we'll see in a few minutes, we would. So doing this as an equation would look like this. But I agree with, I'm sure, what most of you guys are saying. Why don't we just add 82 and 57 and subtract from 180? And of course, we can do that, right? So that's probably going to be our preferred method for something like this, just because it's a little bit faster. How would we check it? We would add them, right? 57 and 41 is going to give us 98. 98 plus 82 gives us 180, so our solution would be x is equal to 41 degrees. For something like this, we have several different ways of doing it, right? So one way we can do it is we can say, well, I know that the whole triangle is equal to 180 degrees, and I know that this is 90 of those degrees. So this is one equation we can use. Somebody else would raise their hand and they'd say, well, I know the whole thing is 180, but I know this is 90, so that means that these two have to add up to the other 90. So that's how somebody else would do it. And then I'd always have someone else that's going to say, well, why don't we just find the angle? They would say, since the 2x and the 42 are 90, I can do 90 minus 42, right, which is going to give me 48, and then 2x has to be equal to 48. And all three are equally valid. So what's going to happen if I solve the green equation here? I get 2x equals 48, which is the same thing I got with what I did in red. And of course, x is 24. Then if I solve the blue equation, I'm going to combine the like terms. And I'm eventually going to get the exact same thing I got with the other two methods, right? 2x equals 48, x is 24. So for something like this, we want to do two things. We want to find the angle and find the value of x. So we would say x is equal to 24, but we'd say 2x is equal to the 2x degree angle is a 48-degree angle. So we'd want to make sure we do both. So here we don't really have too many options, right? The last one we had 3 options that were technically a little bit different, even though they ended up being the same. Here, as far, I guess you could really convolute it by calling each of the, 180 minus some sum or something like that. But the easiest way to do it is just going to add them and set that sum equal to 180. So that's going to give me 8x minus 20 equals 180, which gives me 8x equals 200, which gives me x is 25. And now I need to go back and substitute, right? So what's 2x minus 12? Well, 2x minus 12 is 2 times 25 minus 12, right, which is 38 degrees. And 3x plus 2 is 3 times 25 plus 2, which is 77 degrees. And 3x minus 10 is 3 times 25 minus 10, which is 75 minus 10, which is 65 degrees. Now, we have no guarantee whatsoever here that we did anything correct, right? We got answers. I could have got answers with x is 10. If I used x is 10, on top I would get 8. On the left, I would get 32. On the right, I would get 20. Is that right? Of course not. Why is it not right? Because they don't sum to 180, right? We know if our value of x is correct, and only if it's correct, these three angles will sum to 180. So let's check. I've got 77. I've got 38. I've got 65. I would expect these to add up to 180. And when we check it out, we see that they do add to 180. And that's our proof that we did this correct. And x is 25, and the three angles are 77, 38, and 65. So now we're going to revisit something we did with our last session, right? So I said one of the limitations that some of us had, I know a lot of you guys already have done, you know, the triangle stuff and the angle stuff we should have done a little bit at the end of 7th grade. But now we can use, in addition to our knowledge of, you know, corresponding alternate interior, alternate exterior, we can use the fact that we know the sum of the angle measures in a triangle. So I've got 80 and 40 is 120, meaning this is going to be the other 60. So I know that to get angle 4, I do 180 minus 80. I know to get angle 5, I do 180 minus 40. I know that the 40-degree angle and angle 3 are alternate interior angles. And I know that the 80-degree angle and angle 1 are alternate interior angles, or I could have done angle 1 plus angle 2 plus 3 is 180. So just another kind of tool that we can use for when we have one of these types of problems. All right, so here's your now try, right? So you can pause it, and we're going to solve for x and then substitute. So for the first one, I can do this, even though I would generally just do 2x plus 3x is 90, or even just cut right to 5x equals 90 if I was doing it. So now I've got 5x plus 90 is 180, which means 5x is equal to 90, which means that x is equal to 18. So if x is equal to 18, 3x is equal to 54 degrees, and 2x is equal to 36 degrees, and 36 plus 54 is 90, plus the other 90 will give us our 180. For the second one, right, we don't really have, like I said, too many choices. 2x plus 12 plus 4x minus 8 plus 5x is equal to 180. So when we combine the like terms, we end up with 11x plus 4 equals 180. We end up with 11x is equal to 176. So I get x is equal to 16. And now we have to go back and substitute. So if x is equal to 16, 5x is equal to 80. If x is equal to 16, 2x is equal to 32, plus 12 is 44. And 4x, if x is 16, 4x is 64, minus 8 is 56. And again, really no guarantee that this is correct until we check it. So 44 plus 56 is 100, plus 80 is 180, and there's our proof that x really was 16. My three angles are 44 degrees, 56 degrees, and 80 degrees. All right, so we're going to be consistent with what we've been doing for the last week or so. All right, so this would have been our classwork. We'll call it our homework. Again, none of these geometry topics are in our Algebra 1 book, since we technically don't do any real geometry in Algebra 1. You're going to solve for x and find the measures of the angles as the direction state. All right, so for each of them, you're going to write an equation. You're going to solve for x. You're going to go back and substitute, and it'd be a good idea to check to make sure that we have our answers correct.